Hi everyone, welcome to Number Sense at Mrs.Geetha's classroom. Today we are going to add and subtract algebraic expressions using algebra tiles. Today we are going to use algebra tiles to add or subtract algebraic expressions. Algebra tiles allow students to better understand ways of algebraic thinking and the concepts of algebra. So let's look at the key. If you have a long green tile with a positive symbol, that's a variable. So for example, x, positive x. And if you have a long red tile with a negative symbol, that's a negative variable, which is negative x. And if you put an x and a negative x together, a green and a red variable tiles together, that will make a 0, and we call that as 0 pair. And if you have a small tile with a positive symbol, that represents the number 1. And if you have a red tile with a negative symbol, that's a negative 1. And if you put a positive 1 and a negative 1 together, you get a 0. So first let's see how to write an algebraic expression shown by the algebra tiles. So the first expression, you can see that's a positive variable and we have 3 number tiles. So this is equal to x plus 3. You can use any variable. You can use any letter for the variable. I just used x. So that is x plus 3. And look at the second expression. We have 2 variables, which is x plus x, which is 2x plus, and we have 2 red tiles, that's negative 2. So that is the expression, and we can write that as same as 2x minus 2. So that is the expression represented by this algebra tiles, by the algebra tiles that is on B. Now let's look at C, where we have 2 variables, that is 2x. And look at the number tiles. One positive and one negative will make one 0 pair. And another positive and negative will make another 0 pair. So those 2 sets of numbers are gone. And we have only 3 positive numbers left. So that will be positive 3. So the variable, the expression is 2x plus 3. The next expression, we have 3 positive variables, which is 3x. And how many 0 pairs can we make with the numbers? One positive and one negative is 0. Another positive and negative is 0 pair. Another 0 pair. So we have 3 0 pairs. So those are all zeros. And what is left? 1, 2, 3, 4 negatives. So that I can write minus 4. So that is the algebraic expression represented by the tiles that is on D. Explain to me how you got that.
So there's 3 of x,
Okay.
and then plus normal 3, and then you're adding, so you don't have to write any sign. So you're adding 2x. Oh, that's 2x. 2x. And then plus a negative.
Okay.
So that's it.
So what happens?
These 2 cancel each other out, so we can
That's a 0 pair.
Yeah, and then these 4. Oh wait, no, these are all positive. Yeah, these are all positive. Then that's 5x.
5x.
5x plus positive 2.
Positive 2.
Wait, what is this? X3
X
plus 3.
X plus 3. Okay.
2x minus 1.
2x
And
minus
then
1. And you're adding them, right?
Yeah.
Okay.
So then this from this one plus this would equal 0 pair.
That's a 0 pair.
So now that's
okay.
like out. And then if you put these over here, then you have 3x's plus 2 positives. So it would be
3x plus 2. Okay, good. So the answer is 3x plus 2. Okay.
Okay. So I'm going to put 3 x tiles or x bars minus 3. So I'm gonna get my negative tiles because you're subtracting. So we're gonna put also 2 x tiles plus 4 positive tiles. Okay. So now we're gonna look at our 0 pairs. So we have these and these. So if we take 3 of these and 3 of these, so then now there's only 1 of these left. So it's 5x plus 1.
Can you write that down, please?
Yeah. Are you in my class?
We're supposed to be Queen Elizabeth.
Box.
Oh. Yeah.
So in this lesson, we are going to add linear expression. A linear expression is an algebraic expression in which the exponent of the variable is 1. So that means you will have only the variables with exponent 1. X, the exponent of x is 1. Y, the exponent of y is 1. Only the variable with exponent 1. There will be no variable with exponent other than 1, like x to the second power or x squared, and there won't be any y to the second power or y squared. So we are going to do only linear expression. So write the sum of two algebraic expressions modeled by the algebra tiles. Then use algebra tiles to simplify the expression. So we are going to simplify the expression using algebra tiles. So let's see what algebraic expression is modeled by the first algebra tile. So you can see there is an x. This is an x, 1x, and there are like positive 1, positive 1, positive 1, positive 1, and positive 1. So that will make x plus 5. That's the first expression. And we are going to add that to, let's look at the second expression modeled by the algebra tiles. We have two variable, which is 2x plus and we have negative 3, because all of them are negative 1, and this is also negative 1, and this is also negative 1. So 2x plus negative 3 or 2x minus 3. And when you combine them together, you can see we have three variable tiles, which is 3x plus how many number tiles are there? We can see one positive 1 and one negative 1 will make a 0 pair, and another positive and negative will make another 0 pair. Another positive and negative will make a 0 pair. So we have 3 0 pairs, and we are left with 2 positive numbers. So that is 3x plus 2. That will be your answer for the sum of these two expressions, which are x plus 5 and 2x plus negative 3. Same way you can do the next expression. You have 2x and we have 1, 2, 3, 4, 5, 6, 7, 8 negatives. So that means minus 8 or plus negative 8 plus 3x. 3 tiles, 3 variable tiles, so that is 3x. All of them are positive, and we have 1, 2, 3, 4, 5 positive ones. That will give you positive 5. Now what is the sum of those? So when I put all the algebra tiles together, I will get 5x there are no zero pairs, so it's 5x plus. How many zero pairs can I make with this positive and negative ones? So negative 1 and positive 1, that's one zero pair. Another negative 1 and positive 1, that's another 0. Negative 1 and positive 1, again that is 0. Negative 1 and positive 1, that's 0. Negative 1 and positive 1, that is 0. So we have 5 zero pairs and we are left with 3 negatives. 3 negative 1, negative 1 and negative 1. So we have 3 negatives. So the answer is 5x plus negative 3, or you can write that as 5x minus 3. Now let's find the difference of two algebraic expressions modeled by the algebra tiles. Then use the algebra tiles to simplify the expression. So let's look at the algebraic expressions. This is x plus 3 minus x plus 1. So you're taking away 1x plus 1 from 1x plus 3. So I have 1x and I'm taking away 1x. So that will give me 0x. There is no x. And from 3 numbers, 1, 2, 3 positive ones, I'm taking away 1 positive. So I have only 2 positives left. So the answer is 2. Just 2. There is no variable because I had only one variable and we took away that variable. Look at the next expression. The first expression is x minus 4 subtract x minus 3. So you are taking away x minus x. You are taking away x from x, so there are no variables left. And we have 4 negatives and you are taking away 3 negatives. So 1, that is gone. You are taking away, you are not adding them. So these are not zero pairs, but 1, negative 1 minus negative 1 is 0. You are taking away the negative ones. So we left only negative 1. We left with. So let's find the sum or difference of the following expressions. So the first expression is a subtraction problem where you have 8 minus u minus, there is no number outside, so let me just take 1 times 5u plus 1. So they want you to take away 5u plus 1 from 8 minus u. So if I write, if they don't have any number outside, so consider that as a 1. So it will be easier for you to distribute that negative sign. Now I can rewrite that as 8 minus u plus negative 1 times 5u plus 1. Now you distribute the negative 1 to each and every term inside. There is no number outside of 8 minus u, so that means it's a positive 1. Positive 1 times 8 minus u is 8 minus u means 1u. So let's write 8 minus 1u as 8 plus negative 1u plus, let's multiply 5u by negative 1, that is negative 5u plus negative 1 times 1 is negative 1. Now let's combine all the like terms. I can see 8 and negative 1 can be combined, and negative 1u and negative 5u can be combined. So negative 1u plus negative 5u is negative 6u plus 8 plus negative 1, that means you have $8 and you spent $1. So you have $7 left. So that will be the answer for that expression. That will be the answer for that problem. Subtract 5u plus 1 from 8 minus u. So your answer is negative 6 times u plus 7. Number 2, it's an addition problem. So that's plus 1 times 8z minus 7. So I don't need to, if I multiply by 1, I get the same expression. So we can just write this as like with no parentheses. So negative 8z plus 4 plus 8z minus 7. So you can see, you can combine the like terms, negative 8z plus 8z. That will be a 0 pair. So there are no variables left. Negative 8z plus 8z is 0 and positive 4 minus 7. So I'm on positive 4 on a number line. I'm moving back 7. So I reach at negative 3. So your answer is negative 3 for that problem. Let's look at the next problem, where you have a subtraction problem. Again, we have a distributive property to do because there is a number outside. So let's write the first expression, 12 plus 7 and 2/10 of b, and there is no number outside. That means we are taking only one time of that quantity, 12 plus 7 and 2/10 of b, minus, that means plus negative. Please consider that as plus negative and do the distributive property. This is also plus negative and do the distributive property. So that is negative 3 times 9/10, which will be 2 and 7/10 of b. That is plus negative 2 and 7/10 of b. And if you multiply negative 3 by negative 4, you get positive 12. So we distributed the number outside, which is a negative 3, to each and every term inside. So you get 12 plus 7 and 2/10 of b plus negative 2 and 7/10 of b plus 12. Now let's combine all the like terms. I have a 12 here, another plus 12 here, and positive 7 and 2/10 of b and negative 2 and 7/10 of b. So you subtract the coefficient because one is positive and the other is negative. So you are going back from 7 and 2/10 on a number line. So that means 12 minus 7 is 5. And this is 6. 6 minus 2 is 4. So 4 and 5/10 of b plus 24. That will be the answer for that problem. And we used a lot of concepts that you learned before, like adding decimals, multiplying the decimal by a whole number, and positive and negative integer addition and subtraction. Now let's look at another problem where we have fractions as coefficients. We are going to distribute the fractions. So let's see, 1/2 times w, which is 1/2 w, minus, or you can write plus negative 1/2 times 6, plus 1/4 of w plus 1/4 of 12. So we just distributed the number outside to each and every term inside and removed the parentheses by using distributive property. Now let's combine all the like terms. No, let's simplify the terms. So it's 1/2 of w plus negative 1/2 of 6 is 3 plus 1/4 of W plus 1/4 of 12 is 3, which is 1/4 times 12 over 1, which is 3. Now you can combine the like terms. So you know 1/2 of W plus 1/4 of W is 3/4 of W. It's like 50 cents plus another 25 cents is 75 cents, or make the denominator same and add them. 1/2 plus 1/4 is 3/4, so 3/4 of W. And look at the constant terms. Negative 3 and positive 3 will make a zero pair, so there are no constant terms. We have only one term in the answer, which is a variable term, which is 3/4 W. 3/4 is the coefficient and W is the variable. So that will be the answer for the fourth problem. Now let's look at a word problem. It's about banking. You start a new job. After W weeks, you have 10 W plus 120. That means 10 times the number of weeks you worked plus $120 in your savings account. So every week you're putting $10 into the saving account, and you had already $120, and 45 W plus $25 in your checking account. So you're depositing more money in the checking account. In your checking account, you're depositing $45 every week, and there was a $25 left before you start saving it. So write an expression that represents the total in both accounts. So we are going to write down both the expressions. So total will be, you add both the expressions. So 10W plus 120 plus 45W plus $25. So that means you can combine the like terms. So 10W plus 45W, both of them are positive. You're just adding the coefficient 10 plus 45, which will give you 55W. So that means every week $55 altogether in checking and savings account, plus 120 plus 25 was left in the at the beginning. So that means 120 plus 25 is 145. So that will be the answer for the problem, and it's in dollars. So you can say 55W plus $145. So after how many hour weeks, if you substitute the number of weeks here, you will be able to calculate the total amount in both accounts.